All right, so we are going to work on the slope of lines today to help us identify parallel and perpendicular lines. So quickly, just going over the warm-up. With order of operations, with these fractions, even though like number 4, it doesn't have parentheses, they are just kind of assumed there. So don't feel like, ooh, get that, go away. Don't feel like just because there's not parentheses, it's you do division first. So for number 1, 7 minus 5 is 2, and 8 minus 3 is 5, so that would just be 2 over 5. For number 2, we would have negative 3 minus 6. If those parentheses confuse you, just ignore them. Negative 3 minus 6 is negative 9, and then 5 minus negative 1 would give us a big fat positive, so 5 plus 1 is 6. So then to simplify, both of these can be divided by 3. So negative 9 divided by 3 is negative 3, and 6 divided by 3 is 2. So we have negative 3 over 2. For number 3, we have another big fat positive minus a negative. So 4 plus 4 is 8. And then 2 minus 2 is 0. So anytime you have a number divided by 0, that is undefined. And I'll be explaining the reasoning behind that here shortly. And then for number 4, negative 3 plus 3 is 0, divided by 1 minus 6 is negative 5. So 0 divided by any number is still 0. But when 0 is in the denominator, that's when we have issues. So the deal with dividing by 0, it is actually, there is a legitimate reason. So if we had 2 or 10 divided by 2, think of it, if I had 10 dots, okay, 10 divided by 2 is how many groups can I make of 2? So I can make all of these groups of 2, and I have 5 groups, so it's 5. Voila, I have my answer. If I have 0 divided by 2, I have 0, so nothing. Divided by 2, can't make any groups of 2, so there's 0 groups of 2. Now, if I do 10 divided by 0, if I have my 10 little dots, oh wait, let me do the blue so it's a little bit thicker. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I'm doing 10 divided by 0, I'm trying to break it into groups of 0. So over here with that 10 divided by 2, we were making groups of 2. Because I'm trying to make groups of 0, that just doesn't make any sense. We can't make groups of 0. So since no number exists, any number divided by 0 is said to be undefined because there is not a number that helps us see what that relationship is. So anytime you see a 0 in the denominator, like 10 over 0, that is always undefined. Okay? So starting with slope, the slope of a line in a coordinate plane is the number that describes the steepness of the line. So you think about it, if I have a line like this and a line like this, my first line would have a slope of, let's just say it's like 3, and then my second line would be a slope of like 1/3 instead, because with the one on the left, we rise more than we run, and with the one on the right, we run more than we rise. So bigger number, steeper slope. Okay, and so any 2 points can be used to help you determine the slope of a line. And you can, if they're on a graph, you can count it, or you can use the actual slope formula. So with slope of a line, the rise is the difference in the 2 y values. So looking at this picture, my rise would be how far up do I go, which would be y2 minus y1. That's this part right here. The run is the difference between the x values of 2 points. So the run is over here. It's left and right. And it's that x2 minus x1. It's the difference between the x values. So the slope of a line is the ratio of the rise to the run. So if x1, y1 and x2, y2 are any 2 points on the line, the slope of the line is m equals y2 minus y1 over x2 minus x1, or difference in y's over difference in x. So I'm going to do 2 of these with the slope formula and 2 of them just by counting. So to do AC with the slope formula, A, let's see, is at -2. 1, 2, 3, 4, 5, 6, 7. So A is at -2.7 and C is at 4.2. So if I wanted to use the slope formula for AC, I would subtract my y values. So 7 minus 2 over -2, since I started with 7, minus 4. So then 7 minus 2 is 5, and -2 minus 4 is -6. And if you notice, with this one, if I rise 5, 1, 2, 3, 4, 5, and run 6 to the left, 1, 2, 3, 4, 5, 6, that will put you right at A. So if I wanted DC, and actually, I'm going to actually count DC. So DC has a rise of 1 and a run of 1, 2, 3, 4, 5, 6. So my slope for DC would be 1 over 6, or you can do the actual slope formula if you want. For AB, since I have that point for AB, I could also get my ordered pair for B, so that would be at 3, 7. Since it's a horizontal line, some of you may just remember that horizontal lines have a slope of 0, but to just prove it to you, you subtract your y value, 7 minus 7, over -2 minus 3. That would give me 0 over -5, which is just 0. Okay, so any horizontal line is always a 0 slope. And then for AD, D is at -2, 1. So if I did the formula for that, I would have 1 minus 7 over -2 minus -2. Well, minus -2 makes a big fat positive. So then I have -6 over 0. And anytime you have a number divided by 0, it is undefined. We don't have a number to represent this. Okay? And again, you could also just count. Kind of up to you. So with slopes, you always want to read them left to right. So when you see a line, if it is going from left to right up, then you're going uphill and it is positive. So think about a little ski man. He has to ride his skis up the hill. That would take him forever. But if you had that same little ski man over here, now he's going to be zooming right on down because it's going down from left to right. So that would give you a negative slope. Then you also have a 0 slope and an undefined slope. So we do have a little memory trick to help you remember your horizontal and vertical lines. So when you have a horizontal line, it has a 0 slope, and it is y equals some number. So that's Hoy. Hoy bucks is what we use. But Hoy tells you horizontal line is always y equals something and your slope is 0. The V is for vertical. And with vertical lines, you always have undefined slope. And the line is always represented by an equation x equals some number. So if you remember Hoy-Bucks, it can help you remember all of your rules for horizontal and vertical lines. So moving on down, parallel and perpendicular lines. That's really what we're worried about. So in a coordinate plane, 2 non-vertical lines are parallel if and only if they have the same slope. So they have to rise and run at the same rate. So for perpendicular lines, 2 non-vertical lines are perpendicular if and only if the product of their slopes is -1. And vertical and horizontal lines are perpendicular. Now, rather than multiplying your slopes together all the time, you can also just remember opposite reciprocal. So when you have A over B, your opposite reciprocal, opposite tells you to change your sign, and reciprocal tells you to flip. So we change the sign, positive becomes negative, and then we flip that fraction. And if you were to multiply these together, you would get -1. So perpendicular lines, they also just slope our opposite reciprocals. Okay, so if a line has a slope of, let's say, 1/3, then the slope of the perpendicular line would be -3/1 or just -3 because we changed the sign and flipped the fraction. So to list the slope of the perpendicular lines, this one we change the sign to a negative and it becomes 2/3 instead of 3/2. For B, we have 1/4, so we change the sign and make it 4/1. For C, we have -5/6, so we change the sign so it's positive and flip the fraction, so 6/5. And then if I have a slope of 0, that's a horizontal line. So the only way to have a perpendicular line to a line that has a slope of 0 is to have a vertical line. And a vertical line always has an undefined slope. Okay? So are lines with slopes 2/3 and -12/8 perpendicular? It may seem like it's not, but if we simplify -12/8 and divide them both by 4, that becomes -3/2. And you notice the sign has changed sign, and flipped fraction. So these are indeed perpendicular. And our symbol for perpendicular looks like an upside down T. So when we are determining whether lines are parallel, perpendicular, or neither, you still want to graph it just to see it, but just know that you can't assume anything based off of your graph. So we have 0, 2, which would be right here, and then -1, -1. Boop. And then we have x is at 3, 1, and y is at -3, 3. Oops. So although it may seem like they're perpendicular, you do always have to verify it. So we are going to use slope formula. So for UV, the difference in my y's would be -1 minus 2. And since I started with the -1, I'm going to have to come back. -1 minus 0. -1 minus 2 is -3, and -1 minus 0 is still -1, so that just makes it a positive 3. So then for x, y, my y value, 3 minus 1 over -3 minus 3. Quick check with this is if you look vertically, 3 and -3, that is one of your ordered pairs, so you are good. Slope formula biggest issue is people mess up their ordered pairs. So 3 minus 1 is 2, and -3 minus 3 is -6, which would simplify divided by 2 to -1/3. So then looking between these, our sign is opposite and the fraction is flipped because this is like 3/1. So because of that, we know they are perpendicular. So you would say UV is perpendicular to XY. Boop. Perfect. So next one, we only got 2 more examples. We have WX. So 3, 1, and 3, -2. 1, 2. Ooh, that gives us a vertical line. Oh, my hands are all shaky today. And then we plot -2, 3 for y and 4, 3. Oh, and we have a horizontal line. So what I would say is if you graph it and you see a vertical line and a horizontal line, it's kind of hard to dispute because with vertical lines, your x's are the same, and with horizontal lines, your y's are the same. Then you can safely assume that they are indeed perpendicular to each other. So WX is perpendicular to YZ. And if your OCD is kicking in, you really just want to have those formulas. -2 minus 1 over 3 minus 3 gives me -3/0, which is undefined. And then for YZ, you would have 3 minus 3 over -2 minus 4, which give you 0 over -6, which is just 0. So 0 and undefined are perpendicular. So last example. For BC, oops, maybe not that quite that big. There we go. B is at 1, 1, and C is at 3, 5. So just sketch it and see how we do. And then D is at -2, -3, and 0, 1. So it looks like these might possibly be parallel, but we'll double check. So starting with BC, we would have 5 minus 1 over 3 minus 1. 5 minus 1 gives us 4, and 3 minus 1 gives us 2, which simplifies to just 2. And then for DE, we'd have 1 minus -3 over 0 minus -2. These negatives make big fat positives, so we have 4 divided by 2 again, which just simplifies to 2. So since the slopes are the same, we know that BC is parallel to DE. And FYI, that is your parallel symbol. Ooh, if I can make it look like parallel. All right. So whenever you're doing this, when in doubt, use the slope formula to subtract your y values. But that is the extent of slope. You can also count rise over run if you want, but your homework is down on the bottom, and it should be page 185. And if I'm wrong on that page number, then let me know, but I'm pretty sure it should be chapter 3, section 5 in your textbook. Happy working!